All right, now we're on to section 2.4, dividing polynomials. We've added them, we've subtracted them, we've multiplied them, but we didn't divide them. And it's a much different process. So to kind of get the idea, we're going to do some long division here. We're going to see how many times 3 goes into 58. Now 3 goes into 5 one time. 1 times 3 is 3. And we're going to subtract that. Then we bring down our next number, which is an 8. 3 doesn't go into 2, of course, but it does go into 28 9 times, 9 complete times. 9 times 3 is 27. And we got that 1 left over. So it was 19, remainder 1. Or 19 and 1/3, because we have that leftover 1 and we're dividing by 3. All right, synthetic division is used to divide a polynomial by a linear expression. It has to be x minus a, meaning x plus something, x minus something, but the coefficient of x is 1, and it's just a linear term, just one binomial. So here's how we do our synthetic division. We take the opposite of what we're dividing by. We're dividing that big polynomial by x minus 3. So we're going to take a positive 3 and using synthetic division, divide out that x minus 3. And then we put the coefficients of our problem that we're dividing in order. So we have 2x cubed, negative 7x squared. We don't have an x term. We got to keep a place there. It's all about place value. And then negative 4. Again, that's our x cubed, that's our x squared, that's our x, and there is 0x, and then our number. So that's our setup. When we start working on this, the first number we just bring directly down. But then now, every number down there gets multiplied by our number, our divisor, the 3 here, and then put into the next spot underneath the number that's already there. So 2 times 3 is 6, and we put it there, and we add down. We get negative 1. Negative 1 times 3 is negative 3. We add down, we get negative 3. Negative 3 times 3 is negative 9. And we get a negative 13 there. So our rightmost column is our remainder. Then our number, then our x, then x squared. So our final answer, and this is our depressed polynomial, it just means our answer when we divide. So it's 2x squared minus 1x minus 3. And then the way we write our remainder is we basically put it as a mixed number, negative 13 over, now what are we dividing by? X minus 3. So if we were to multiply this back out and then add in the negative 13, we would get back to the original problem. So that is our answer here. We'll try another one. Divide 3x cubed minus 5x plus 10 by x minus 1. So we take the opposite of what's in the parentheses, well, of our divisor. Then 3x cubed, 0x squared, negative 5x, and 10. So we bring the first number down, just 3. 3 times 1 is 3. Add down again, we get 3. 3 times 1 is 3 yet again. Negative 5 plus 3 is negative 2. Negative 2 times 1 is a negative 2, and we get 8 there. So again, the rightmost column is our remainder column, then our numbers, then our x squared. So 3x squared plus 3x minus 2 plus 8 over x minus 1. And that's what it is when we divide. Now, example 3 kind of uses the same equation. I think they're trying to show us something. Evaluate p of 1, meaning x equals 1, substitute it in. So p of 1 equals 3 times 1 cubed minus 5 times 1 plus 10. 1 cubed is 1 times 3 is 3. Negative 5 times 1 is negative 5. And then we got the plus 10. 3 plus a negative 5, negative 2 plus 10 is 8. Where have we seen that before? Well, we saw it as our remainder when we divided by x minus 1. Well, that gives us our remainder theorem. If p of x is divided by x minus a, then the remainder is equal to p of a. So we can plug it in and get the remainder as well. So given the polynomial p of x and c equals negative 5, so we'll do it the remainder theorem way. We got negative 5 cubed. Make sure you put these in parentheses when you substitute them in, especially when we have negatives. So that's 125. That's 250. That would be, negative 145 plus 24. Leave that 254. Of course, just like everything else, we need to check. We don't want to be wrong. We don't want to do too much. Yes. So that is our remainder. Now, can we show that it is the remainder? Yeah. Negative 5, 1, 10, 29, and 24. So we can do our synthetic division. Bring down our 1. 1 times negative 5 is negative 5. Add down, we get 5. 5 times negative 5 is a negative 25. So we get 4. 4 times negative 5 is negative 20. We add down, we get 4. Oops. That's why it's not looking right. This should be on negative 125. Negative 5 cubed is negative 125. I did that to prove a point. Well, to make sure that everyone, or that we know that everyone makes mistakes. So our remainder is 4, and that's exactly what we have. So either way you want to do it, it works. All right. What is a factor? A factor is a number that divides evenly into another number. So is 4 a factor of 24? Yes, because 4 times 6 equals 24. It's a factor. We can see it. Is 4 a factor of 39? No. 39 is actually prime. It's the only factors we have are 3, 13, 1, and 39, which is not 4, so it's a no. So the factor theorem. We say x minus a is a factor of p of x if when dividing by x minus a, the remainder is 0. Or p of a equals 0. Whichever way you want to do it. All right, let's look at example 4 here. Is x minus 6 a factor of that big mamma jamma? So we'll do x equals 6, and we're going to do p of 6. So we're just substituting in, make sure it's in parentheses so you don't make any silly mistakes, or any mistakes for that matter. So we got a lot to go there. 6x to the 4th is 1296. Then we have negative 1728. We get positive 576, negative 138, and a minus 6. So we want to combine all that and see if it is 0. And hopefully we do it right this time, and it does equal 0. So yes. How do we know? Well, the factor theorem, because our remainder when dividing is 0. And we could have done our synthetic division. It would have given us the same thing. See if we can kind of set that up here. So 6, we got 1, -8, 16, -23, and -6. 1 goes down. 1 times 6 is 6. We add down again. -2 times 6 is -12. We add down again. 4 times 6 is 24. We add down again. And 1 times 6 is 6. We got a remainder of 0. It went in evenly. So it is a factor. Now, is x plus 3 a factor of this thing? Well, let's see. So let's do synthetic division first this time. So we take the opposite of what we're dividing by, then the coefficients, 0x to the fourth, minus 5x cubed, plus 9x squared, minus 1x, plus 3. So we bring down the first number. 1 times -3 is -3. We add down. -3 times -3 is a positive 9. We add down. 4 times -3 is -12. We add straight down. -3 times -3 is a positive 9. We add straight down. Multiply it by -3 and add straight down. So again, that's our remainder, our x, our number, our x squared, our x cubed, and our x to the fourth. So it looks like no, it's not a factor because we have a remainder when we divided by it. But just to double check, we can substitute this in just like we did the last problem. And let's see if we get the same thing. Hopefully we do. So we'll go step by step through this. -3 to the fifth is a -243. Then -3 to the third times -5 is a positive 135. -3 squared is positive 9 times 9 is 81. Minus a -3 is +3. And then we have that other +3. We have -243 plus 135 plus 81 plus 3 plus 3. And we do get -21. So no, it's not a factor because we have a remainder of -21 when dividing, not 0. So it all kind of goes into that, either substitution or synthetic division, and then knowing what a factor is. So our homework is a couple pages after it. Keep practicing and get her done.